Dead galaxies and ominous red beacons haunt the cosmic abyss, whispering of a universe far older and more enigmatic than we dared to dream. The James Webb Telescope has uncovered something extraordinary. Entire galaxies that perished billions of years ago, alongside eerie crimson anomalies dotting the interstellar void. These revelations challenge the very foundation of our understanding of how galaxies are born, evolve, and die. Prepare for a discovery so staggering it could force science to rewrite the story of the cosmos. The James Webb Space Telescope, launched with great excitement on Christmas Day 3 years ago, has transformed how people view the vastness beyond Earth. This immense cosmic observatory is the largest and most powerful instrument ever sent into space by human hands. Its mission is not merely to drift in the void, but to peer deeper into the universe than anything before it, unveiling stars and galaxies from the cosmos's infancy. This advanced space eye has explored realms nearly 14 billion years into the past, offering clearer insight into how things have evolved since the moment of the Big Bang. But now, one surprising discovery could change everything we thought we knew about how the universe began. The discoveries made by this massive orbital marvel have astonished even the most experienced scientists. These findings are not only impressive, but also challenge long-standing ideas about the workings of the universe. Every 365 days, it gathers fresh data that uncovers secrets about distant galaxies and the space between them. Astronomers once thought they understood how galaxies formed, but this revolutionary observatory has revealed ancient galaxies that existed when the universe was merely 200 million years old. Being over 13 billion years away, these findings are forcing experts to reconsider existing theories about galaxy formation. These primordial star clusters defy current models by appearing far earlier than expected in cosmic history. Then come the colossal black holes. Two enormous voids, each with a mass approximately 50 million times that of the Sun, were captured in an extraordinary celestial dance. This cosmic spectacle occurred when the universe was less than 1 billion years old. Researchers are now working to understand how such gargantuan objects could have formed so swiftly. Typically, black holes grow slowly by accumulating matter over billions of years, but these seem to have bypassed that gradual process. A particularly intriguing find involves a dormant black hole. With a mass 400 million times that of the Sun, this quiet giant seems to have consumed so much material that it entered a phase of cosmic hibernation. Comparable to a massive bear resting after an enormous feast, this event occurred about 800 million years post-Big Bang. Though it continues to absorb surrounding matter, its activity has slowed dramatically, making it appear nearly inactive. Another exceptional revelation pertains to a trio of enormous crimson galaxies. Each of these stellar giants, weighing roughly 100 billion times the mass of the Sun, formed when the universe was just over 1 billion years old. Their rapid emergence poses new questions about how quickly such massive formations could occur. Scientists are still grappling with the conditions that enabled these red behemoths to develop so rapidly. This advanced space sentinel also confirmed a phenomenon first proposed by Albert Einstein. Light from a distant quasar, an extremely bright galactic nucleus powered by a black hole, was bent and duplicated 6 times due to the gravitational influence of 2 massive galaxies. This rare gravitational lensing event provides valuable data about dark energy, the mysterious force thought to be accelerating the universe's expansion. One more enigma involves the so-called Hubble tension, referring to the inconsistency between 2 methods of measuring the universe's expansion rate. One approach involves nearby stars, while the other looks at the cosmic microwave background, the faint glow of the Big Bang. These methods should yield the same result, but they don't. This sophisticated instrument has confirmed that this discrepancy is real, hinting at unknown physics beyond current models. A young stellar nursery known as the Serpens Nebula was also captured in exquisite detail. Located approximately 1,300 light-years away, it serves as a birthplace for new stars. Despite being relatively young, around 2 million years old, it has already produced numerous stars. By examining such regions, astronomers aim to better understand how stars and planetary systems emerge. Prior to the operation of this groundbreaking observatory, knowledge about planetary formation was limited. Thanks to its exceptional infrared sensitivity, it can now observe protoplanetary disks, rotating clouds of gas and dust encircling young stars. These disks represent the initial stages of planetary development. Studying them could reveal more about how our solar system formed more than 4.5 billion years ago. One of the most thrilling breakthroughs came when signs of potential life were detected on a distant exoplanet. This far-off world, designated K218b, orbits within the habitable zone of its star, suggesting conditions suitable for liquid water. Methane and carbon dioxide were detected in its atmosphere, along with a faint trace of dimethyl sulfide, a molecule on Earth produced exclusively by living organisms such as plankton. While this is not definitive proof of life, it provides enough reason for astronomers to keep a close watch on this intriguing planet. The success of this stellar explorer is due in large part to its cutting-edge technology. Its primary mirror, coated in gold and spanning over 21 feet in diameter, gathers light from extraordinarily distant sources. Unlike previous instruments, it operates in the infrared spectrum, enabling it to pierce through thick clouds of gas and dust. This capability has been crucial for observing the earliest galaxies and star-forming regions. Another key feature of this observational powerhouse is its capacity to accumulate vast quantities of data. Each observation yields information not only about the observed object, but also about the surrounding space and time. By analyzing light that has traversed billions of years, researchers can reconstruct conditions that existed in the early universe. Closer to home, it has examined planets and moons within our solar system, offering fresh insights into the atmospheres of Jupiter and Saturn, as well as the composition of asteroids and comets. These findings help scientists piece together the history of our solar neighborhood. Colliding galaxies are another spectacle this observatory has captured. These cosmic smash-ups can trigger starbursts and reshape entire galaxies. Studying such interactions aids in understanding the dynamics of galactic evolution. It has also kept watch over the demise of stars. When stars exhaust their fuel, they can explode in brilliant supernovae or collapse into dense remnants like black holes. Observing these events provides crucial data about stellar death and the birth of new cosmic phenomena. Additionally, this high-tech marvel contributes to mapping dark matter. Although dark matter is invisible, its gravitational effects can be measured by observing how it bends light from distant sources. By charting these distortions, scientists can infer the distribution of this mysterious substance. Some galaxies observed by this space sentinel act as time capsules, containing stars and elements formed in the universe's early days. These ancient relics offer snapshots of conditions billions of years ago, helping scientists build a timeline of cosmic evolution. The first year's findings set the stage, and what came next took things even further. Let's break down what's been happening with the James Webb Space Telescope over its second full year in action. The cool thing is, we're not just looking at pretty space pictures. We're getting closer to figuring out what's going on in our universe. And this cutting-edge observatory is leading that charge. We're talking about Jupiter and its moons first because, well, they're right in our backyard, cosmically speaking. Now, do not expect a flood of new pictures this year. The big hits from last year, like those crystal-clear images of Jupiter, Uranus, Neptune and Mars, still stand out. Instead, scientists have been busy digging into the data. Let's kick things off with Ganymede, the biggest moon in the solar system. It is covered in ice, and underneath that ice, there is probably a massive ocean of water. There might even be geysers shooting stuff into space, but nobody has confirmed that yet. What the Advanced Space Observatory did find on Ganymede was hydrogen peroxide all over the place. This happens because charged particles from Jupiter's magnetosphere and solar wind slam into the Moon's icy surface, breaking up molecules and creating clouds of hydrogen peroxide. Mapping this stuff helps scientists figure out how Ganymede interacts with its surroundings. Next up is Io, the most volcanic moon in the solar system. The telescope detected sulfur dioxide coming from Io's volcanoes. When scientists compared these findings to images from the Juno spacecraft, they got a better idea of how Io's constant volcanic activity affects its environment. And then there is Europa, another icy moon hiding a liquid ocean beneath its frozen crust. One big question scientists have is how much interaction happens between the ocean and the icy surface. The observatory found carbon dioxide in specific spots on Europa, a weird find because with no atmosphere, carbon dioxide should not stick around on the surface. Something must be replenishing it, hinting at possible geysers. No geysers were directly spotted though. Moving farther out, we have Uranus, and this year we got an even better image than last time. Uranus is tilted on its side, so the telescope caught it from a pole-on view. You can see the planet's rings clearly, including one super faint ring that was not visible in last year's picture. Uranus spins fast. One rotation takes only 17 hours, so it is tricky to capture clean images. This high-tech instrument proved it can handle fast-moving targets, not just Uranus, but also Mars, Jupiter, and Saturn. Beyond these images, it has been busy gathering data on other solar system objects like asteroids and Kuiper Belt objects, but we will stick to the highlights. One of its main goals is to study exoplanets and their atmospheres. It does this by watching as planets pass in front of their stars. By analyzing the light that filters through a planet's atmosphere, the telescope can figure out what is in it. Pretty wild, right? This year, a lot of focus went to the TRAPPIST-1 system, which has 7 Earth-sized planets, 4 of which are in the so-called habitable zone where liquid water could exist. Everyone is dying to know if these planets have atmospheres, but so far it only has data on the 2 innermost planets, TRAPPIST-1b and TRAPPIST-1c. And guess what? No atmospheres there. At least nothing like Venus' thick carbon dioxide atmosphere, which scientists had hoped to find. Instead, these planets are more like oversized versions of Mercury, rocky, airless, and blasted by intense radiation from their star. The real anticipation is for the outer planets, but scientists are still working on the data. It is looking like we will have to wait until next year to get answers about whether any of the other TRAPPIST-1 planets have atmospheres. Here is a fun one. This powerful eye in the sky may have found evidence of a moon orbiting a brown dwarf. Brown dwarfs are kind of like failed stars, not quite massive enough to ignite hydrogen fusion. This particular brown dwarf, with a surface temperature around 200 degrees Celsius, showed something surprising: methane in its atmosphere. Methane should not really be there unless something is heating up the atmosphere from the outside. One theory is that a moon orbiting the brown dwarf might be causing these effects. The moon could be interacting with the brown dwarf's magnetosphere, generating auroras and heating things up. This would be the first hint of an exomoon around a brown dwarf. A pretty big deal if confirmed. Way back, astronomers spotted a star system called Beta Pictoris, about 60 light-years away. Using the old Spitzer Space Telescope, they saw a ton of dust around the system, which they figured might be caused by asteroid collisions. Now, decades later, this modern space marvel took another look, and the dust was gone. This supports the idea that Spitzer caught a one-time asteroid smash-up in progress, providing a rare glimpse of what might happen during the chaotic early days of a star system. There has been talk lately about a new kind of exoplanet called a Hycean world, basically a planet with a thick hydrogen atmosphere covering a liquid water ocean. These worlds could have habitable conditions, even if they are not in the traditional habitable zone around their stars. The best candidate so far is a planet called K2-18b, about 120 light-years away. It is around 3 times the size of Earth, and the observatory detected methane and carbon dioxide in its atmosphere, a possible sign of a Hycean world. Even more intriguing, there was a faint hint of dimethyl sulfide, a chemical that on Earth is mostly produced by living organisms like phytoplankton. But before anyone gets too excited, there are other possible explanations. The signal could have been an error caused by overlapping methane signatures, or the planet could be something entirely different, like a mini Neptune or a lava world. The observatory also spotted methane in the atmosphere of an exoplanet called WASP-80b, a warm, Jupiter-like planet with a surface temperature around 550 degrees Celsius. Methane is interesting because it does not last long in an atmosphere unless something is constantly replenishing it. While on Earth, methane often comes from life, it can also be produced by volcanoes and other geological processes. Finally, this instrument has started mapping weather on exoplanets. One standout case is WASP-43b, a tidally locked planet that always shows the same face to its star. It measured the differences between the day side and night side, finding that the night side is covered in clouds, while the day side has clear skies. It also detected massive winds blowing at speeds of over 8,000 kilometers per hour, transporting material from the hot day side to the cooler night side. By studying these kinds of weather patterns on large exoplanets, scientists hope to understand how things might work on smaller, Earth-like planets around red dwarf stars, many of which are also expected to be tidally locked. New insights changed what we thought we knew, opening the door to more surprising discoveries. Water showing up on planets outside our solar system. That has been one of those head-scratchers in science for a long time. People have always wondered how Earth got its water in the first place. If you think about it, Earth sits way too close to the Sun for water to just chill on the surface without help. Without our atmosphere and that magnetic field keeping us safe from the Sun's intense rays, any water hanging out would have boiled off into space early on. Scientists figured that water had to arrive later, but where from? One popular idea is that icy comets from the outer solar system swung by and delivered it. Maybe those icy objects from the Kuiper Belt brought in some water, or maybe Earth just scooped up icy dust and particles over time as it formed. Fast forward to today, and thanks to the James Webb Space Telescope, there is real-time evidence of something similar happening elsewhere in the universe. This space observatory caught water particles floating inward from a region as far out as Neptune's orbit in another solar system. This fits perfectly with the top theory scientists have about how planets get water, called the icy pebble drift theory. Seeing water delivery happen in another planetary system is a big win for understanding our own planet's watery origins. And if you thought water delivery was fascinating, how about clouds made of sand? Sand clouds are a thing on a far-off exoplanet called WASP-17b. This giant, puffed-up planet is much larger than Jupiter, but with a lot less mass, making it super lightweight for its size. Because it is so close to its star, temperatures skyrocket to around 1,500 degrees Celsius. With an atmosphere that hot, scientists got curious about what kind of weird chemistry could be happening up there. They found aerosols in the atmosphere, like the ones on Earth, except instead of water vapor or dust, these are made of quartz, or basically tiny sand particles. Imagine a world where the clouds are not made of water droplets, but grains of sand floating high up in the sky. This discovery raised some serious questions. To get sand, you normally need silicon oxide to first melt down into a liquid, then cool and crystallize into quartz. But with temperatures that high, the usual process would not work. Instead, it seems like extreme heat and pressure on WASP-17b forced the silicon oxide into forming crystals directly, leading to those bizarre sand clouds. Just picture a world with winds whipping around grains of sand in its skies. It is nothing like the calm blue skies we know. Speaking of strange worlds, let us talk about rogue planets. Planets that do not orbit any star and just float around in space. This might be one of the wildest things the high-powered observatory has found so far. Hubble first spotted a few of these loner planets decades ago, but this advanced instrument blew everyone's minds by detecting over 500 of them in the Orion Nebula alone. Some of these rogue planets are even smaller than Saturn. Even crazier, scientists found 42 pairs of these planets locked in orbits around each other, now called Jupiter Mass Binary Objects, or jumbos. Now the big mystery is how these things form. Did they start off in regular planetary systems and get kicked out into space by gravitational chaos? Or did they somehow form solo out in the middle of nowhere? And if it is possible for one to form on its own, how do two of them end up together, orbiting each other? Scientists have way more questions than answers right now, but one thing is clear: rogue planets are not rare. They might actually be super common in our galaxy. Just imagine billions of these lonely worlds drifting silently through the Milky Way. On top of that, this discovery helps us rethink what is out there in space. People tend to picture the galaxy as stars with planets orbiting them, but it turns out there might be tons of free-floating planets without a home star. Despite the excitement, no, these rogue planets do not explain dark matter. Still, it is a mind-blowing realization that makes us wonder what other surprises are out there. While we are on the topic of life's building blocks, there is another breakthrough worth mentioning. Everyone knows Earth needs water for life. But life also requires organic molecules, compounds made of carbon, nitrogen, oxygen, and other elements. One theory says these molecules might have formed here on Earth after water arrived. But astronomers are finding more evidence that many of these organic molecules were already floating around in space before Earth even existed. Using this cutting-edge space telescope, scientists detected a molecule called methylcation, or CH3+, in the Orion Nebula, the same region where those rogue planets were found. This molecule is believed to be a crucial building block for creating more complex organic compounds. The tricky part is that methylcation does not like to stay by itself. It tends to combine quickly with other atoms. What surprised scientists was finding it in a place with intense ultraviolet radiation, which was expected to destroy such delicate molecules. Instead, it looks like the ultraviolet light might actually help keep replenishing the supply of methylcation, setting the stage for even more complex chemistry. This discovery is a big deal because it suggests that the ingredients for life were scattered across the universe long before planets like Earth formed. Life's building blocks did not just appear out of nowhere on our planet. They were already out there, waiting to be assembled into something more complex. If the ingredients for life are scattered across the universe, does that mean life is inevitable everywhere? Share your thoughts below, leave a comment, and don't forget to subscribe.